Today is alternate sources of fuel. So before we jump into the discussion, I want you all to understand why are we discussing alternate sources of fuel. I mean, we also have coal, natural gas, petroleum, right? Why can't we just use them? So this news is in context that recently IPCC released its report which states that if we were to achieve the target 1.5 degrees Celsius that was set under the Paris Agreement, we need to peak our carbon resources, our carbon dioxide emissions, greenhouse gas emissions by 2024. They need to peak by then, and by 2030 the levels should have been reduced by 43% of present levels. By 2030 they should be reduced by 43% of present levels, and by 2024 they should peak, right? That means that they should not increase any further. So this is all to achieve the goal of 1.5 degrees Celsius temperature increase from pre-industrial levels. So to achieve this goal, definitely we can't rely on the conventional sources, right? We can't rely on conventional sources. We need to go for more green, more environmentally friendly resources, right? This is where this discussion on alternate sources of fuel comes in. Now let us discuss one of them, each one by one. So before we jump in, we need to understand what is the difference between fuel and energy. So the relationship between fuel and energy is that the purpose of fuel is to store energy, right? If you produce energy, you need something to store it to. So the purpose stores the energy so that it can be retrieved later on and they can be easily transported. So what is now moving on our discussion. So now we know what fuels are. Next is alternate fuels. So alternate fuels, they are unconventional fuels because we are looking for an alternate to the conventional fuels like fossil fuels, right, as well as nuclear materials. So we are looking for an alternative. Some examples of alternate fuels, they include biodiesel and bioalcohol. And if you look at this infographic on your right hand side, these are the different ways through which you can produce energy, right, to make the fuels. For example, if you wish to make blue hydrogen, you can use either of these resources: bioenergy, solar battery, hydroelectric, geothermal, windmill. I'm sure you all are very much familiar with these renewable sources of energy. So these are alternative fuels, biodiesel, bioalcohol, and other propane, auto gas as well, that we'll be discussing shortly. Now before we move on, I just want to say that the purpose of this video would be purely descriptive in nature, right? It will be purely descriptive. It means that there is not much to analyze. Alternate fuels are there, they are there. So the purpose is I'll be very descriptive as to what sources of fuels are there and how many are there, right? So now moving on, biofuels. So here bio means biological. That means that they should have a source from biological matter, right? It could be for example, plant-based, right? So the biofuels, they can be either made from food grain stocks, for example, soy, corn, wheat, right? Or they can be made from non-food materials, and these are known as advanced biofuels. So non-food materials, for example, on marginal lands that are not used, you can grow some crops on them and you can use them. Municipal waste that you can use. So these are advanced ones as compared to the conventional biofuels. So within biofuels there is also another categorization, right? Now other types of fuels, for example, algae fuel. So for me, algae fuel is specifically very interesting because they will have a minimal impact on freshwater resources. They are available in abundance, right? You can use them, and they will also be relatively harmless if spilled, right? For example, recently oil tankers, you might have heard, they leaking in the ocean, that leaves very disastrous impact on the ocean life. So when used algae, like for example in the shipping industry, they can be very much useful there. However, the most important lagging point behind all of these fuels is that their scalability. their production is still not at the advanced stages. They are still very basic, right? So for example, there's a discussion on electric vehicles, right? The electric vehicles, they can't be used in heavy trucks as of now. In heavy trucks, the lithium ion batteries, they can't be used there. So that is the lagging point behind all of them. But anyway, the point is that we have to we always need a starting point from where we can start, and then end is the result. We can't just focus upon the destination first. So all of these fuels, although they are in their initial stages, most of them, they are in their initial stages, but I expect them to grow further in the future, right? Now let's get back to the discussion. Next is biodiesel. So biodiesel is made from animal fats or vegetable oils. They are drop-in biofuel. That means that they are compatible with existing diesel engines. So this basically means that you do not have to modify the existing diesel engines for specifically suited for biodiesel. You can use your existing diesel engines. And the main benefit that they offer is that they are also sulfur-free. So which means that it helps in the environment as well, in cleaning the environment. Now moving on. The next kind of fuels that are available with us are alcohol fuels, right? And alcohol fuels, they can be either produced chemically or biologically, and there is no difference between them, right? They serve the same purpose. It is just that they are formed from two different ways, right? And if they are formed from biological processes, they are simply known as bioalcohols, otherwise known as simply alcohol, right? For example, there are different types of it like methanol, ethanol, propanol, butanol, and all of them can be used in internal combustion engines as well. Ethanol is produced through a fermentation process. You do not have to remember this for your examination. This is just for your information. You only need to know what are alcohol fuels and different types of them, right? For example, methanol, it is usually produced from natural gas, right? Plus it can also be produced from biomass as well, making it more environmentally friendly. Right. Here it talks about the ethanol blending program of the government to reduce the fuel prices as well as to help the environment. Because if it is green, that means that you would require lesser number of petrol, right? Using less petrol means that releasing lesser number of greenhouse gases in the environment. So this ethanol blending program of the government, it will serve two ways. I'll repeat again. For example, by reducing the petrol prices as well as by improving the greenhouse gas framework of the environment by releasing them less. You can have a look at this infographic for more details. Now the next type of fuel is ammonia fuel, right? The main benefit of ammonia fuel lies in the shipping industry, right, wherein it can reduce greenhouse gas emissions, and this will also be on line with the goals of the MARPOL Convention for ships. So MARPOL Convention, it mainly focuses upon pollution from ships. Pollution from ships. So the main benefit would lie, it would also serve to fulfill the purpose of the MARPOL Convention as well. Green ammonia is produced when it is produced from energy resources that are 100% renewable and carbon free. It could be through solar, wind, or any of those energy. It is done through the Haber process, right? And then the next process is mentioned here. You can have a look at it, right? Now there are different, this infographic reflects two ways through which shipping industry is powered. It can be either through oil derived fuels, that is more polluting, or through zero carbon shipping, which can be done through biofuels, ammonia as I just discussed, or hydrogen that I'll be discussing shortly, and synthetic carbon based fuels as well. So these are the different ways through which shipping industry can reach zero carbon goal, right? Now moving on. Now we've got carbon neutral and negative fuels. So what are carbon neutral fuels? They are synthetic fuels. That means they are produced synthetically, such as methane, diesel, fuel, or jet fuel, right? And they can be produced either from renewable sources or nuclear energy, right, to be considered carbon neutral. So they need to be produced either from renewable sources or nuclear energy to be considered carbon neutral, right? If you produce it from oil, then it would no longer be carbon neutral fuel. So methane, we just discussed it in the context of alcohols, right? Jet fuel, right? It is also there. So all of these fuels, when produced from renewables or nuclear energy, they can be known as carbon neutral. So although the fuel in itself may not be, but the process that is behind it, if it is carbon neutral, then they become a carbon neutral fuel. So what are synthetic fuels? So synthetic fuels, they can be obtained from either syngas, that is a mixture of carbon monoxide and hydrogen, right, or a mixture of carbon dioxide and hydrogen. So there are two ways through which it can be achieved: syngas or through the mixture of carbon dioxide and hydrogen. And syngas is derived from gasification of solid feedstock such as coal or biomass. It is a bit technical, but you can just have a look at it just to know what is a synthetic fuel or syngas. Carbon neutral fuels have been proposed for distributed storage of renewable energy. As I discussed in my today's current affairs series, the main problem that lies with renewable resources is that it is very difficult to transport them over long distances because of the storage issues. So these carbon neutral fuels can help store the renewable energy, right, so that they can be transported over long distances. This is the carbon footprint of the various industries. You can have a look at it. For example, electricity and heat industry, it contributes to around 18%, road transportation around 20%, agriculture around 15%. So this is the division of it, of the carbon footprint. This infographic, you can have a look at it. Now the next is compressed air. Who knew that air could also be used as a fuel? So but it can be through the usage of piston engine. You can compress the air and you can use it as fuel, right? And unlike hydrogen, compressed air is about 1/10 as expensive as fossil fuels. So it is even cheaper than hydrogen. So imagine cars running with compressed air. So compressed air could also be used. Currently it is used in certain engines as well, especially flights, certain specialized flights, this compressed air. Now next is propane auto gas, and then there is CNG. CNG, you all are aware that it can be through renewable natural gas or biogas. So it can be produced from either of those ways. It is a bit technical, so you can have a look at it. I do not want to waste the time here by discussing point to point of all of these things. Now this is the world's electricity generation. The highest percentage is through coal. The highest energy percentage is through coal. Then after that it is through gas, then nuclear energy, right? So you see that coal, gas and nuclear energy, they form a very significant amount, and this hydrogen, this hydro source, wind source, biomass as well as other, they form a very less percentage of it. Though with time, as they become more cheaper, you can expect them to get more affordable, right? And there are other statistics and interesting infographics that you can have a look. You can use them as your points in your mains questions. Now the next and final one are hydrogen based fuels. So there are different ways. Green hydrogen, it produces no greenhouse gas emissions. Blue hydrogen and grey hydrogen, they are almost similar, right? They are both formed from natural gas. However, blue hydrogen is more carbon neutral. It is more low carbon hydrogen because the resulting carbon is trapped and stored, whereas in grey hydrogen it is not trapped, right? And now the next one is black and brown hydrogen, that is made using fossil fuels. And there is also pink, purple, red hydrogen made using nuclear power. Then there is turquoise hydrogen, yellow hydrogen using solar energy, and the white hydrogen that is underground and there are no ways of extracting it. We could do that in future, but currently there are no ways of extracting it. Now here there is an interesting infographic that shows current global dedicated hydrogen production, right? So currently the major hydrogen production is done through natural gas, then through coal, then through oil and electricity. So it is still done through natural gas, right? So it would depend if it is blue or grey hydrogen, depending if the resulting carbon dioxide is stored or released. So I have a question for all of you. So if this resulting natural gas is trapped, pardon my poor handwriting, If this resulting natural gas is trapped, so what would it be called? Let me know about this, because I've just discussed it. Okay. Now moving on. This was all the points that I wanted to discuss with you all in today's session. These were the alternate sources of fuels that are there, that are important. For example, we just discussed alcohol fuels, ammonia fuels, that is important in the shipping industries, and also as well as biodiesel and more. So with this, I would like to end today's session. And I'll try to bring more such sessions wherein they could be helpful to you and for examinations. Thank you everyone for listening.